In order to understand if we have a good visualization, we first need to know what people are trying to do with it, and then we can judge whether or not it helps people do whatever that is. The thing that people do with it is referred to as tasks in HCI. Tasks are basically the stuff that people do that we want to support with, whether it's an interface, a visualization, a device. Tasks are where it's at. In the framework of analyzing visualization that we've been working with, the what, why, and how, this is definitely the why. Why is the task being performed? So that's what are people doing? Why do they want to do it? What kind of decisions do they want to make? You should have read Chapter 3 in Visualization Analysis and Design already. And an overview of what's in that chapter is that tasks are basically broken out into actions and then target. Actions are the things that people want to do, like analyze or search or query, and the targets are the data or parts of data that they want to understand. And we're really going to be focusing on actions here. So tasks are what we start off with, and tasks really are the core of how any kind of analysis or validation of human-computer interaction systems is done. And that really does apply whether or not you're creating an interface for a car or a stove or an app, or in this case, a visualization. Why all the focus on the tasks? Essentially, we want to know what people want to do because that's going to help inform the design. We don't want to build a thing without thinking about what people are going to do. Now that's done. People do just go ahead and build stuff without really analyzing people's tasks. And when they do that, you end up with really bad systems. And I'm sure you've all probably run into this. For example, you go to use a website and there's the main thing that everybody wants to do on that website and it's impossible to find, right? I run into this all the time, like on the iSchool website. I just want to find a list of like faculty documents, and it's the only place you can get them as a faculty member. They're not in the faculty section. They're not in any reasonably labeled section. You have to click some weird link at the bottom to get there. It doesn't have an easy name. I always struggle to find it. And so that means whoever built the website either didn't consider this to be an important task or didn't think of it as a task at all and just kind of buried that information. So to avoid hiding the stuff that people actually want to do, you want to have a list of tasks first. If you've done software engineering, it's similar to use cases. So use cases are more like, what are people going to use this software for? It sounds a lot like a task, and if you're comfortable with use cases from software engineering, this will feel pretty familiar. That said, you don't need any software engineering background to do this. We're going to build up our understanding of tasks from scratch. So here we're focusing on visualization in particular. What are the tasks that people want to do in visualization? We have actions, which you saw in our outline from the book. The main actions that people want to do are analyze things, search for things, and query things. That is performed on a whole bunch of different targets. So we may want to analyze all the data or analyze just the attributes. We may want to analyze network data in particular. We may want to query network data. And so you can put these two things together to sort of come up with a task for a particular visualization application. What we're going to do in the rest of the lecture is focus specifically on the actions of analyze, search, and query and what that means. So let's start with analyze. Analyzing is highlighting this difference between consuming and producing information. Consuming, if someone's going to consume information, they want to discover things, they maybe want to present with it, they want to enjoy interacting with the data. If you're producing, you may want to annotate or record or derive new insights. Here's an example analysis task. This is showing us a tool called Lineup. It's a tool for exploring multi-attribute rankings. It's essentially a table of data. You can think of it a lot like Excel, and it looks like Excel except for these columns here. And that's because instead of just showing numbers in those columns, it shows them as little bar graphs and it pushes them together to make a big bar over here. It allows you to sort and arrange them in different ways, make composite columns. So it's kind of like a spreadsheet with some visualization steroids that allow you to really look at data in a lot of different ways. You should have looked at the Lineup tutorial before you watched this tutorial, because I'm going to give you an exercise to do in Lineup in a minute. It takes a little bit of explanation before you can jump into it. that tutorial is 5 minutes and should have given you most of the explanation that you need. So essentially what we want to do for an analysis task is to take something like a data set and go through it and look for what are the kind of insights that we might be able to find in there. What is the relationship between different values? We may want to actually present that data, create a visualization that I can share with someone that shares that kind of insight. So this is what we're doing with an analysis task. We're taking a bunch of data and we're looking for insights that are in there. We're looking for ways to present the data to other people. We're looking for ways to just enjoy the exploration of the data. So let's do a practical exercise. And for this, you're going to use Lineup. So you're going to open up Lineup's university rankings. They're at this list. This is all web-based, so you don't have to download anything. So click on that link. It's also provided in the Canvas version of the course. And then I want you to just look for things like, how well does UMD rank for the different topics that are listed there? How does it compare to other universities? Are there any other things that are surprising or new discoveries that you make in there? These are classic kind of analysis questions. Lineup supports the analysis task that these kind of questions hit on. Don't spend a huge amount of time on this. 5 minutes is fine. You don't have to make any new columns or do anything crazy with it. Just try sorting by clicking on the name of the columns. Find University of Maryland in there and compare it to other things. There's a discussion board topic for this exercise, so post whatever answers or insights that you have there. Read through other people's comments. So go ahead, pause the video, do that, and come back, and then we'll talk about other types of actions that people do in visualization. Okay, so we've talked about analysis. That's basically trying to find insights in the data. Search is another, where we want to go find stuff that we know is in the data. So it's a really different task. With analysis, we're sort of exploring what's there. We're looking for insights. For search, we want to find specific things. We can break that down into whether or not we know what the target is and whether or not we know its location. So, for example, if we know what the target is, say we want to find the University of Maryland in our data set, that target is known. It's the University of Maryland. Do we know its location or not? So maybe we have our table of data sorted alphabetically, so then we do know where it is. Maybe we have it sorted by ranking, and then we don't know where it is. So that would give us different subtasks where if we know the target and we know the location, we're essentially just going to look it up. If we know the target but we don't know the location, then we're going to try to locate it. We're going to try to find it on the list. Sometimes we don't know what the target is, but we know what the location is. So maybe I want to find the top ranked university. If I have it sorted by ranking, I know right where it is. It's at the top. And so I'm just going to browse through the data and I'll be able to find the answer to that question. If I don't know the target and I don't know where it is, then I want to go exploring. So maybe in the case of a university example, I want to find universities that are both affordable and well ranked, but I don't know what those are and their location's tricky. I may have to explore and sort the data in different ways to find it. So search tasks can be any of these 4 things. Here's an example, different than the one that we just talked about. This is a tool called WordTree. It's a visual search tool for unstructured text. Unstructured text is generally referring to text that people write, as opposed to structured text like a thesaurus or a dictionary where things are very clearly structured and in a particular order. So in WordTree, we have an alphabetical list of the main words with their context, and you can pick a phrase and you can see all of the context for it. So here you can see we start with the text, I have a dream, and then it splits off that there's a couple of options here. This could follow, I have a dream that one day, this nation, and it goes on from here. If we follow it on the other branch, we could say, I have a dream today. I have a dream that one day, and then follow it to different branches. So it allows you to explore the way text flows into itself. I want you to go ahead and do another practical exercise here. You're going to use this tool. So we're going to use WordTree. Again, this is online. The link is here. It's also provided on Canvas. So you're going to open that up in your browser. You're going to find an interesting data set that's provided. You can certainly use MLK's I Have a Dream speech. The text of that is available at this link. And go exploring in there, see what you want to find. Or maybe there's a particular word that you want to start with. You have a known target and you want to find it. So go ahead and explore in there. See if there are any surprises, new discoveries, anything that you didn't expect. And again, there's a discussion board topic for this exercise. So please post, even if it's just a couple sentences, your thoughts from doing the exercise. And again, pause the video to do this, but only spend about 5 minutes on it. The final task that we have for the kind of actions that people want to do with visualizations is to query. And that's actually to identify characteristics of a single target, to compare things, to study multiple targets and compare them to one another, or to summarize things to get an overview of many targets. So if we go back to the original university example, I may say want to identify what are all the statistics for the University of Maryland. So I'm going to just find the University of Maryland, look at what's there in the table. Maybe I want to compare the University of Maryland to the University of Virginia. So I'm going to pull those two pieces of data out and then compare them. Or I may want to summarize. So for all the universities in Maryland, what's the average ranking? What's the average student to teacher ratio? And get an overview of them that way. Another example we're going to look at with a tool called Kashif. We're going to focus on that. Actually, we're spent a whole week talking about that later in class. But it's a browser that gives you data visualizations from a bunch of different perspectives. So again, I've got an exercise. I want you to actually get your hands on this and try it out. This is another web-based tool, so go ahead and click on the link here. Again, that's provided on Canvas. And explore the data that's available. This is going to give you a quick opportunity to learn how to use the tool. It's much more complicated than the other two that we looked at here. And again, we'll spend a lot of time on this later, so I don't need you to master it here, but I just want you to see what you can find trying that out. Again, not too much time, maybe 5 to 10 minutes on this one because there's a little bit more for you to see. But if we go ahead and visit that site, you'll see that there's a lot of data that's available in the data set that it provides here on foodborne disease outbreaks. So here's just a quick peek. I've got it sort of small in the window here, but you can see that we have a bunch of different windows. If I mouse over, say chicken, I see the other windows adapt. Same thing for fin, fish, and beef. The map's really small here because the window's small, but if you try this, you'll see that you can mouse over and all of the windows adjust. So you get multiple views on the data, and as you select different parts of it, it's going to highlight things in other sections. So it allows you to do the kind of query tasks that you want, along with some of the other ones as well. Okay, so do that practical exercise, and that's going to kind of be the end of our tasks. I want to highlight that there are 3 major tasks that we've been talking about, and we've talked about them on a sort of higher level. We've looked at these main actions: analyzing, searching, and querying. Those can be done over different types of targets, which are different forms of data or different aspects of the data. There are sub-ways of doing all of these things, which we laid out here. But ultimately, when you're creating a visualization, you want to think about which of these do you want to support. It may be all of them. It may be just one. And you're going to put that in the context of what you're doing. So if you're NASA and you have this data about errors or damage on the solid rocket boosters, what do you want to do? What task do you want to support with your visualization? Probably you want to support a query. People want to be able to compare different launches and different levels of damage with the temperature to see a pattern there. They may also want to do an analysis where they're discovering patterns that are in the data. They may want to present that data in a way that is going to help them argue for their position. So these tasks we will emphasize again as we're going through how we actually analyze visualizations to see which ones have better quality or perform better than others, because tasks are going to be the main way that we focus on that.